Welcome to today's demo from Introspect Technology. Today we'll be showcasing the SV2C 8-lane 28 gigabit per second personalized SerDes tester. And we will be describing just basic channel controls on pattern generation and error detection using this ultra-compact and highly affordable test system. So the setup we have on the bench here is very simple. We have the SV2C system on our bench as illustrated here. The system has 8 independent pattern generators, all running up to 28 gigabits per second, and 8 independent error detectors and pattern receivers for analysis. For today's demo, one of the channels is connected to the oscilloscope, and the remaining channels are connected in loopback. In addition to the main channels on the SV2C, there are auxiliary clock controls like in all Introspect products. So there are 2 clock generators that can be used to drive a device under test or to attach to a bench instrument. And there is also a clock reference input for synchronization to other tools. Today the channel is connected to a high bandwidth oscilloscope with embedded clock recovery in it. So we'll go ahead and start the demo now. For the demo, I have 2 pieces of software running in front of me. One is the Introspect ESP software environment, and the other is the scope environment in the background here that we'll see in a second. Controlling the SV2C is all performed using the Introspect ESP software environment. And as always, the software environment is able to understand different form factors. And today, it's attaching to the SV2C 8-channel 28 gigabit per second system, and the light at the bottom left here is lit to green, which basically says that I'm already attached and connected to the system. In terms of operation, the SV2C feels and is programmed exactly the same way as the SV1C. So there's the concept of a TX channel list and RX channel list, global clock config, as well as measurement functions. So BER measurement is the test that we will be doing here. And then custom functional code where you could create automation loops, and this is one of the automation loops that I will perform here to demonstrate preemphasis tuning. So the concept is the same as the SV1C operation. We'll go ahead now and start a test. I have the pattern generation set up, and then I have the BER measurement test set up. So I'll go and click Run. And so we've now transitioned from the parameters tab to the logs tab, and we're seeing what the system is doing. So first we'll see that the channels here at the top, basically channels 1 to 4 past sync, and channels 6 to 8, but not channel 5. And that's perfectly understandable because channel 5 is connected to the oscilloscope. In any case, all the channel results are being displayed here, and as you can see, we're seeing 0 BER operation at today's demo, which is 25.78 gigabits per second. I can go ahead now and disconnect one of the cables just to demonstrate live operation. And so I'm perturbing one of the channels, channel 4, and as you can see there's some errors that are being injected now. And then if I connect the cable back on, I get 0 errors. So this is just a quick demonstration to show that the links are all alive. The log is showing us the instantaneous BER at any one interval, and then the second line here is basically the accumulated errors over all time. So 4 is telling us that it has seen some errors in its history, but right now it's operating fine. When the test is finished, it's taking us from the log tab to the result tab automatically, and in the results tab I basically have the BER icon where I can check the results. I was running 8 channels, but I have results only for 1 to 4 and 6 to 8 because 5 was not connected. The channels are basically, the results are CSV files with error rates, so these are all zeros for channel 1. If we go to channel 4 and look at the various columns here, so we have error count, total count, and count before error, and we'll see that at some point when we started to play around, fiddle around with the cable, we started to get an error count and total counts passed and error rate basically. And then as soon as we connected the cables back on, we got 0 errors. So this was a quick test of BER measurement at 25.78 gigabits per second, which happens to be the frequency that we chose for today's demo here. And we demonstrated 8 lanes operating reliably and performing BER testing basically simultaneously. So since we're all here, we'll go ahead and start the second phase of the demo, which is to illustrate preemphasis tuning on the fly. So this emphasis loop is a Python function that I've created as a simple for loop, and that updates preemphasis every second, and I'll display it on the scope. And the reason we do this demo is suppose we're doing testing on a channel and we need to apply preemphasis. This can help us understand the kind of preemphasis capability that is available from the SV2. So I will go ahead and click Run and just minimize the window here so that we see it on the scope. And so you can see that the scope is updating every second. The main cursor tap is staying at the nominal location, and then the post cursor tap is decreasing. And what we're seeing here, we're now settled at a certain value that I've chosen arbitrarily in this quick demo. But you can see that the eye diagram is still very smooth and very linear, which means that the channel out of the SV2C is also linear. So if I do a pattern lock here, and maybe zoom out a bit. So we can see basically that the preemphasis transitions are very linear as shown in this graph. So this was a quick demo of the SV2C showing pattern generation and error detection at today's demo's rate, which is 25.78 gigabits per second, but truly a 28 gig parallel test system that is the size that fits in one palm. Thank you for attending today's demo.